Planning for secure buildings. Part 1. Balancing security, safety, and sustainability objectives. Introduction. Since the early 1900s, sustainability has become an increased priority with facility projects. Ever since the terrorist acts of September 11, 2001, building owners and occupants are paying more attention to facility security and safety issues. On the surface, it may appear the service secure and safe design has little relationship with sustainable design. Yet, security and safety measures such as those anti-terrorist must consider the total project contents include impact for the occupants' environment regardless of the level of protection deemed appropriate. Further, today's security design is based on multiple hazard approaches for looking at the impact of all the hazards of project, natural, criminal, terrorist, and accidental. The resource page aims to provide designer with the understanding interaction between safety, security, sustainable objectives inside of the whole building integrated design process. Identify areas of synergy, potential and conflicts between sustainability, security, safe approaches. Highlight sustainable opportunities with certain security, safety strategies. With information of the hand, project team can define and understand interrelationship between projects needed to achieve the balanced design solution that will minimize the environmental impacts and ensure health, safety, security, and comfort of the building occupants. Description: integrated design process. It's important to understand that secure and safe and sustainable facilities don't just happen. The level of security and safety and sustainability incorporated within the facility varies greatly from project to project. Achieving the quality of the high-performance facility has a lot to do with the integrated process identified with the embrace of the goals of the project. And safety includes safety, security, sustainability, productivity, accessibility, functional, aesthetic, historic preservation, cost, effectiveness. Early in working the team with the outset with the planning, the design, engineers, all project stakeholders are able to develop a creative solution to the design challenge of the yield with the multiple benefits. For example, the massive reinforced concrete wall can solve the blast protection for its occupants with the passive soul of the devices, saving energy during the facility operation, resulting in more than secure, comfortable working environment. Also, rather than optimize individual system, project team understand the most effective results can be attained by designing various building systems component with the independent parts of the entire surface. The conceptual framework starts the planning phase and carried out through the design construction of the building, activation, operation, whole building approach, aesthetic, engage the integrated design process. B. Secure and safe, sustainable trade-off and the synergies. Given the budgetary other constraints integrated with the secure, safe, sustainable design objective, they often sometimes require compromise and trade-offs for the increased gazing of the more providable daylight and the incorporable with the desire to decrease in gazing to minimize glass hazard. Similar designation surface parking away from the building to provide appropriate standoff device limited extent with the project can meet within sight with the disturbance reduction goals. There inflict inherent conflict changes with the project team and they'll find creative solutions to the issue at hand. Following are key areas of interaction between security, safety, and sustainable goals and measure with the project team and evaluate the value of the benefit, the disadvantages, pursuing the strategies, weighing the against for the project, identified requirement of desired outcome in order to achieve balanced design, engage in integrated design, greatly facilitate the process. With today's concern with the climate change, with the concern with the significantly reducing energy consumption, with reducing greenhouse gas emissions, is more important than ever incorporate secure and safe sustainable trade-off with synergies for the building projects. Site trade-off. Security, sustainability, planning strategies can significantly affect each other. For example, the facility can be increased with the secure with the compromise, hitting of the urban area of the protect, green fields, preserve habitat, natural resources, locating carpool, van pool, parking, and bike racks nearby to more alternative transportation construction under building parking with a minimized habitat, disturbance, installing covered walkways, landscape to reduce heat in the islands and corrosion, erosion. On the other hand, security measures for the building setbacks, standoff distances to create building parameters to restrict the area, access interior, installing barriers, boulders, reinforced planters, and site furnishing to withstand the assault of the moving vehicles, locating parking areas with a remote access to the eliminating under parking building areas to minimize blast effects from potential vehicle bombs may also result in increased development of open space and habitual disturbance and possible erosion. Synergies in erosion control system. The erosion of the soil of the participating wind leave the destruction vegetation design degradation property with sedimentation local water body with unstable design building foundation potential loss of the structural integrity. Erosion control measures can be implemented to stabilize the soil, seeding, mulching, installing previous paving, acting or retaining sediment after erosion has occurred with the earth and dike sediment basements help to reduce the negative impact of the water, air quality, and mitigate the potential damage buildings, foundation, structural system due to floods, mudslides, torrential drain forms, other natural resources. For more information, erosion control, see whole building building design guide, achieving sustainable site design for low impact design practices, low impact development technologies. Landscaping, keeping sustainable safety goals in mind, designers can create a landscape scheme that can once reduce environmental impact with the deter of the crime. With, for example, the landscape elements of the retention pond with the berms can also be used with the corrosion control of the normal storm water, reduce the heat islands will also serve the physical barrier with the control of access to a building, deflect with the effects of the blast, number of climate deterrent and the tree that can help improve the quality of the site, of the provide protection and obscuring assets and people know. However, that trees can also be perpetrators from view. Crime prevention with the environmental design is a strategy that uses the natural acts of the natural surveillance, territorial and boundary definition, reduce opportunity, fear of predatory stranger to stranger crime, improve the quality of life and early condition coordination, sustainable site design, or criminal prevention through environmental design is critical to avoid conflicts between the two strategies. For more information, landscape, whole building design, sustainable optimal site potential, achieving sustainable site design through low impact development, practice low impact development technologies. Water trade-offs. Rainwater collection system, particularly rain collection systems, consist of standalone exterior rain collection tanks located near the building. These tanks are create concealment opportunity with vulnerability exposure where they are located obstructed of space and or minimum standoff distance. Consider integration rainwater collection storage system and the architecture of the facility such as the building facade. For more information, rainwater collection, see whole building design guide, water conservation synergies. Dry fire hydrants. One of the synergistic technologies achieving the water conservation fire safety of the dry fire hydrant. Other hydrants are non-pressurized suction pipe system are permanently installed with a pond or lakes on untreated water instead of municipal water to fight fire. The utilized area with the conventional fire protection areas that cannot handle large volumes of water due to the antiquated systems of during peak use seasons. When there are low water pressure, the hydrants of fire department to become more effective at providing source of the closed source water source to fire risk. Since the dry hydrants are installed with a frost line, but they do not require electricity, the capability to supply water, and with the case of the natural disaster, such as with the hurricane, tornadoes, electrical line with the knockdown during extreme cold and hot weather, where conventional hydrant pipes can freeze and break. Also, dry hydrants help to solve the pressure. Drinking water conserve energy by using rainwater. Doesn't need to be processed for it to be used on firefighting. For more information, see the dry hydrant concept. Constructed wetlands use the wastewater treatment with incorporated with the perimeter of the protection strategy for the control of the vehicular pedestrian access. The more information, construction wetlands, whole building guide, achieving the sustainable site design for the low impact development and low impact development technologies. Energy trade-offs. Because of the opportunity to reduce load and employ with the energy efficient measure for the dependent with the chosen project site with the design site plan with the security with the most optimal energy conservation, installation, on-site power generation, fuel supply, backup power, and or increase power reliability, increase noise development, open space with the habit, the disturbance for the additional equipment system, and the need with the mitigate with the natural habit, the protect with the adjustment without fire, defend again with the terrace acts, increase the building energy land load may affect the energy performance of the roof covered park with the shelters could be used with more photovoltaic modules to provide quiet on-site power, eliminating the need for the additional opening space for power operation generation. Synergies, Building Commission. For the Commission, the systematic process for the ensuring of the documentation of the building system performs according to the specification of the design intent, consistent with the owner's operational needs. The goals of the Commission improve the building and delivery process, provide safe and healthy facility, improve the energy performance of the reduce the cooperation costs, to provide operation maintenance, safe staff, orientation training, to improve the system documentation. According to the U.S. Green Building Council, the Commission can improve the new building and energy and performance 8% to 30% with the more complex with the building type, with the more integrated with the building system, with the more likely the formal building commission process will prove valuable for the using commission with the verify that the project safety sustainable goals have been achieved. Integrated building automation and control systems or BAS. Building automation control systems integrated with the automates the transitional standalone with the building automation control system with the havoc fire lighting and security system with the one comprehensive system enables electronic mounting control of the airflow, space, temperature of the system, performance, energy conservation, fire alarm, security functions, etc. and signal, centralized location, optimized building operation, energy efficiency, indoor comfort, security, and safety. For example, the building automation control systems can be programmed such that the duct with a sensor that can monitor the efficiency of the airflow, can also detect with the contamination of the ductwork, along with the facility manager who can do the reconfigure HAVDAC system in the part of the building, notify with the proper official evacuate occupant safety. Renewable to distributed energy technology. The use of renewable to distributed energy technologies, wind turbines, photovoltaic, geothermal, heat pump, biomass, gasifiers reduce the environmental impact associated with the utility energy production, such as the natural resource destruction, air pollution, water pollution. They also conforms with the potential lower cost, high service reliability, high power quality, increase the energy efficiency, energy security. Thermal mass walls or trumbull walls. Trumbull walls are used to passively heat a space. The trumbull wall consists of the 8 to 16 inch thick masonry stone adobe with the concrete coated with a dark with a heat absorbing material with a face with a single to double layer of glass. The glass has been placed about 3/4 inch to 6 inches away from the wall to create with a small airspace with the heat and sunlight passing through. The glass is absorbed with the dark. The surface is standard stored in the wall. They also cools gradually during the night and slowly releases the stored heat indirectly with the space. The trumbull walls can also serve with double duty with the reduced energy consumption, provide basic protection if integrated with a structural system, and they're made with the reinforced concrete masonry walls break up readily and become secondary fragments during blasts. Window films, dangerous glass shards caused by the natural habit of the accident with the explosion can harm the human building occupants and visitors. Certain of the window film with the design will help hold the shredded glass together, making the glass strong with a more resistant to breakage and improve the safety of the security. In addition to these films can reduce solar heating gain with the glare with the fading with the energy conservation, occupation control materials. Trade-off: buildings should be as safe as the place to live and work. However, the few buildings need the level of 5 secure with the critical national security to prevent unneeded security upgrade with the hence with the use of more resources. The material with a comprehensive threat assessment, vulnerability assessment, risk analysis must be conducted and identify the appropriate level of security of the building. Synergies: there are more security and safety products with the material with the recycled content with environmental preferable characteristics. Examples include reinforcement concrete site with the furniture made of slag or byproducts of steel production, recycled content metal fencing. Both could be used for perimeter access control. Indoor environmental quality: trade-off of gazing daylight. Daylight improves indoor environmental buildings, exposing occupants to the natural light with the result of improving the work productivity, reducing the energy cost, while daylight also contributes to the security of the building and the shedding of light with the otherwise dark corner of it does increase the potential for the glass have the cover of the natural disaster, accident, and blast events. Site located with window of the destination points of the mine with the understanding of the extent of the damage of the conventional glazing still resolve with the blast pressure will wrap around the buildings appropriately. The second step to survive the blast and resistant glazing window film that can be also reject the heat of glare, avoid exterior ornamentation, including certain sun control shading devices that break away easily. Also note the placement of the windows and the doors to allow for the good visibility. Surveillance may interfere with the daily schemes. Natural ventilation versus mechanical ventilation. Natural ventilation has become the increasingly energy efficient and attractive method to provide acceptable indoor air quality, maintain healthy, comfortable, productive indoor climate rather than more prevailing approach of the energy intensive and mechanical ventilation. Power sources are not needed to be operated with the natural ventilation system, so the building occupants maintain their level of comfort for the event of the power shortage of the blackouts. On the other hand, natural ventilation could bring outside contaminants inside for the critical high-risk building. Mechanical ventilation special filters recommended to protect against the possible chemical, biological, radiological agents inside with the interior space. Although more energy will be used, the mechanical ventilation does also precise control humidity, preventing the growth of mold and mildew. Used underfloor and distribution system should not be used in laboratories, other spaces containing hazardous material that could spill on the floor with contaminate under the floor air. Alright, Synergies. Dedicated ventilation exhausters from the exposure of the building with the potential that has chemical, biological, radiological agents negatively impact the indoor environment that can pose the serious threats for the health threats. To maintain and support indoor air quality, protect of the people's health, the dedicated ventilation systems, dedicated to outdoor air systems, dedicated to exhaust systems can be installed, or dedicated outdoor air systems are separately handled with those conditions that deliver the minimum of the required with constant volume outdoor. Be sure to protect all of the outdoor air intake, local discharge points away from them. For more information, see the Department of Health and Human Services, the National Institution, Occupational Safety Health, Publications Guide for the Protection Building Environment of the Airborne Chemical, Biological, Radiological Attacks, May 2002. Guides of Filterization Air Cleaning System Protecting Building Environments, Airborne Chemical, Biological, Radiological Attacks, April 2003. Type building envelope with traditional construction infiltration with the gaps and cracks of the building envelope, excess infiltration with the cold air in the winter, hot, humid air during the summer that can create with uncomfortable indoor environments, including mold and mildew rays. Heating and cooling cooling with a cost 20 to 40% of such unintentional infiltration concerned with the electrical, exterior, chemical, biological, radiological release some of the distance of the building. Such a large-scale attack with decreasing infiltration, improve the comfort, save the energy, control moisture, reduce the indoor pollution, promotes ventilation. Also, tight building construction combination of the building pressurization can be effective with the chemical and biological, radiological protection strategy. Sustainable design considerations and opportunity. The table identify with the sustainable design consideration opportunity employed with the various safety design strategies. We have the safety security strategies, sustainable design consideration, operation, access control, secure perimeter, integrate with the sustainable landscape theme. Use barrier to prevent passage vehicles. Use the natural environmental friendly barriers. Use the reinforced site furniture planners and vehicle barriers. Minimize public entry of the building. Integrate the daylight scheme. Secure vulnerability openings. Integrate daylight scheme. Install electrical access systems and parking elevators. Use the energy efficient system. Consider renewable or distributed energy resources. Several critical functions, mechanical systems, consider dedicated ventilation and or exhaust systems. Surveillance. Locate windows, doors, allow with good visibility, integrate with the daylight scheme. Avoid scheme with a permanent concealment, integrate with the daylight scheme. Define public versus the private interior zones. Use signs or other directional device, manufacture recycled material of the barrier with low volatile organic compound or no volatile organic compound finishes. Avoid blocking lines on the site of the fence and the landscape. Integrate with the landscape of the daylight schemes. Locate public areas wherever they can be easily observed. Daylight lighting, reinforce natural surveillance. Integrate with the building augmentation with the control system, energy system. Consider the renewable distributed energy sources such as solar power, night lighting. Install intrusion devices with the video system. Integrate with the building automation control system, energy efficient lighting and control. Use low light with no light cameras for a clear scene observation. Minimize eliminate with the need of electrical light. Consider the renewable distributed energy source. Use screen and tracking. Integrate with the building automation control system using energy efficient lighting. Consider renewable or distributed energy sources. Blast protection. Design structural system prevent delay of the building collapse. Integrate with the passive solar design. Reuse building configuration best. Resist blast shock waves. Integrate with the passive solar design daylight scheme. Minimize the distance between parking building. Integrate with the alternative transportation plans. Size locate window of the detention points of the mine. Integrate with the daylight scheme. Specify the glazing of the window film with the reduced heat again. Glare and provide blast protection. Use blast and ballistic resistant glazing. Use blast ballistic resistant window films that can also be energy efficient, reduce heat gain and glare, increase strength exterior cladding and non-structural elements, use sustainable materials, consider the thermal benefits, strengthen cladding options, avoid exterior ornament that can break away, integrate with the sun control shading devices. Chemical, biological, radiological protection. Elevate the fresh air intake with integrate with the energy efficient HVAC system. Prevent unauthorized action with the fresh air intake. Specify bars, grates from the manufacturer of recycled steel. Reduce the needs for the utilities. Consider renewables such as daylight, passive solar, protological, geothermal, and distributed energy resources. Apply external filterization, overpressurization techniques. Integrate building augmentation control system. Use internal air filtration technology. Integrate building augmentation control system. Secure vulnerable area to mail rooms, loading docks, mechanical room storage. Consider dedicated ventilation and or exhaust systems. Establish mail handling protocol. Proceed with established emergency plan for the biological attacks. Energy security. Create redundant system. Reduce the need for the energy. We use energy efficient systems. Consider renewable and distributed energy resources. Occupational safety and health. Provide design with eliminated with reduced hazards within the workplace to prevent mishaps and integrate with the safety mechanism, sustainable features with the integrated building augmentation control system to prevent occupational injury with the illness, consider the integrated with the mechanical ventilation system and use integrated building augmentation and control system. Prevent falls from heights. Use sustainable material with the guide rail of the barrier that operate the windows should have safety measures to prevent fall. To prevent slips and trip the fall with the integrated with the daylighting illuminating scheme with the LED lamps for the fixture to use the luminescent devices which require no resource of electrical. Ensure electrical safety follow standard recommended practice in some of the operating of the photovoltaic system with the distributed energy sources that are such fuel cells and micro turbines. Eliminate exposure to hazardous material with volatile organic compound falling metaldehyde, lead, and abscesses all their buildings. Use sustainable material with no volatile organic compound, formaldehyde-free finished panels, etc. Use dedicated ventilation and exhaustion with copy room labs, loading docks, and mail rooms. Provide good air intake, air quality, adequate ventilation, daylighting. Consider the integrated natural mechanical ventilation system, integrated building automation control system. Provide ergonomic workplace to prevent worker-related musculoskeletal disorders. Use sustainable material that include furnishing recycled content, decomposable material with reconditioned furniture. Perform proper building operation maintenance. Implement a total building commission. Use the integrated building automation control system. Provide proper receiving and storing with the handling of consumable materials. Implement a total building commission. Alright, applicant, present, representative example, the California Office of Emergency Service headquarters of Sacramento, California, located 12-acre site with a complex with the Archer project of the adaptive bridge, the former the Martha Air Force Base, and the exemplify with the new next generation open yet with the secure with the sustainable building strategy for the future, included use of landform to control vehicle access, open the daily lit space with a comfortable, productive work environment to back up the fuel cell with energy security. Picture on the right breaks out with some room surrounding with the command with the logistic room with the shielding and exposure of the outside, although the celestial allow with the generous amount with the daylight it ends with the spaces. William Communication Headquarters of the Tulsa, Oklahoma, at the core of the Wilman's Corporate Communications Headquarters of the building of 47,000 square feet, high security network operations center that provides a spacious, dynamic working environment and its occupants. The Defense Intelligence Analysis Center of the Boiling Air Force Base, Washington, D.C., with approximately $100 million project with the first-class 6-story, 450,000 square foot office building design with consolidate uniquely skilled, intelligent personnel currently working in the ideal spaces throughout the region, connect with the existing building via care with the corridor of the project, successfully integrated with the security sustainable feature with the design, creating the energy efficient, comfortable yet very secure facility. For example, the design facility taking advantage of the earth berm behind it would be able to withstand impact with the truck traveling at 40 miles per hour. Pentagon renovations of the Allerton, Virginia energy management control system installed with efficient management of the heating, cooling, lighting system through the Pentagon will allow the official manipulate the building system in the first minutes of the after the 9/11 terrorist attack. The minimize the area of the building that be into the other operated equipment, reducing risk employed with the Pentagon new windows installed for security, energy efficient benefits, helps contain the damage of the attack. Oklahoma City Field Federal Building, Oklahoma City, Oklahoma, the 181 square foot facility replaced the Alfred P. Moore Federal Office Building, which was destroyed in a bomb in 1995. As the owner of the U.S. General Service Administration wanted to build and to be a transparent operation accessible to the public as well as secure sustainability. One of the primary strategies of the landscaping, even light fixtures and streetscape of the items provide appropriate setback distances to serve security barriers. For more information, security sustainable Gordon Merritt, building design construction relevant codes and standard code federal regulation 10434, energy code of the new federal commercial multifamily high-rise residential buildings, Energy Independence Security Act of 2007, and Energy Policy Act of 2005, Executive Order 12976, Assessment of Emergency Preparedness Responsibility, Executive Order 1297-7, Energy Security Committee, Executive Order 13693, Planning of the Federal Sustainable Next Decade, Standard Guidelines, Air Force, Army, Department of Defense, Department of Health, Human Services, Department of Homeland Security, Federal Emergency Management Agency, General Service Administration, Department of Homeland Security, Federal Agency of the Department of Defense, and others in publications, organizations, rating system. Cut the tape there.